in discussing the magnetic field of the Earth, which we just finished talking about, how the magnetic field flips now and then, I'd mentioned that it protects us from radiation from space. So let me go a little bit into that, because the interaction here is something that we call space weather. So what happens is that on the sun, we can have what's called a coronal mass ejection. In a coronal mass ejection, a giant flare or giant release of energy in the sun actually causes the outer part of the sun, called the corona, to sometimes be thrown out from the sun. Coronal mass ejection slams into Earth's magnetic field. Now, Earth's magnetic field protects us from that, but it deflects it around Earth, but that actually will compress and the magnetic field of the Earth a little bit. And so when that happens, then it gives rise to a geomagnetic storm. Now, the geomagnetic storm is the fluctuation of the Earth's magnetic field in here, and that fluctuation of Earth's magnetic field gives rise to many other things. What happens is geomagnetic storms the fluctuating magnetic fields can interfere with radio communication. They can interfere with satellite communication. They can interfere with all kinds of things like that. They can also create currents running up and down power lines. That can knock out power lines. It can create blackouts, all kind of bad things. All this stuff we call space weather, because it is talking about what's going on there, or space physics. Space physics is the area of study that studies space weather. And so the coronal mass ejection can trigger these geomagnetic storms. Well, one of the things that can happen in a geomagnetic storm is it can actually cause these particles in the Van Allen belts to get pushed downwards towards the atmosphere of the Earth. That gives rise to the aurora. The aurora is going to be the auroral displays occur when these things run into the upper atmosphere. And so the northern aurora is the aurora borealis, the southern aurora is the aurora australis. And it has to do with these particles slamming the Earth's atmosphere. Now, you don't want to be underneath that when it happens, because these particles don't just stop right there. They actually come in, they knock electrons off the atoms in the atmosphere. When those electrons grab when atoms grab the electrons back, they give off light. So that gives you the pretty pictures of the aurora. Now, the more disturbed the magnetic field is, the farther south the aurora is visible. And I've actually seen the aurora visible as far south in Texas during a major geomagnetic storm. All this originates from that coronal mass ejection, or big blob of plasma blown off from the sun. Now, in the 1403 class, we talk more about that and how it works, and so we'll talk more about it there, and we'll talk about how the aurora, how the coronal mass ejection is formed and generated, and so forth. For this class, we just kind of are interested in that it occurs, and so the whole idea, though, is space weather is this idea that what's happening to the sun does affect the environment above Earth's atmosphere, the Earth's magnetosphere. The Earth's magnetosphere is impacted by this, and that results in the aurora and geomagnetic storms. If the Earth's magnetic field is in the process of changing, we really have no idea what's going to happen. But we do have all this radiation from space, and so the next topic I want to talk about is actually geomagnetic storms. I mean, that's what happens when the Earth's magnetic field is fluctuating a little bit. So this gives rise to solar terrestrial effects.